All right, our next speaker is Aja Hammerly. Aja is from Seattle. She's a member of Seattle RB. She's been doing Ruby for 7 years or more, and she likes dinosaurs and cats. So she's going to be talking to us today about doing data visualization in Ruby. So thank you, Aja.
Thanks, Josh. My talk today is seeing the big picture, quick and dirty data visualization with Ruby. As Josh said, I'm Aja Hammerly. I tweet at ThagAmizerRB. I'm on GitHub as Thagamizer, and I blog very seldomly at thagamizer.com. I work at Substantial. We're a consultancy in Seattle, and we build awesome stuff. We also have an office in San Francisco. If you want to know more, come talk to me after my talk. And yes, I like dinosaurs. So it's right after lunch, and I think it's a great time for a story. The story may sound familiar, but I promise it is not based on reality. Any resemblance to real people or real companies is purely coincidental. So once upon a time, you were an internet developer, worked at a company that had a website. And one of your customers calls in and says, "Oh my God, your site is too slow. No one can use it. How can you sell this? I'm taking all my money away." And it's a big customer, so your boss gets kind of angry. And your boss calls a meeting. Everyone in the conference room. We need to solve this problem right now. And everyone's starting to panic. And somebody goes, "I know what we need to do. We need to use Java." And another person says, "Nope, nope, the problem is Oracle. Postgres too slow." And the ops guy is like, "Nope, we need more servers. We need 11 billion servers." And you're sitting there going, "You guys, wait. We don't even know what the problem is yet, and you're just throwing solutions out randomly." And maybe you're the junior developer on the team, and everyone's like, "Trust me, I've been doing this for a long time." And someone else says, "I know, my cousin's friend's grandmother is a programmer, and she said we should use COBOL." And the meeting adjourns, and you go back to your code cave, and you're fuming. You're just, and you start digging into the data, because you know that everyone's wrong, and they're just taking wild guesses as to how to solve this problem. And so you start coming with the data, and you figure out what the problem is. And you go running down to your boss's cube, and you barf numbers. And your boss is starting to look a little confused, maybe looking a little bit like this, and says, "So we should use Java?" And you're, why aren't they understanding me? Turns out there's a solution. The solution is to not barf numbers. The solution is to use pictures. And maybe your picture looks like this, your average response time. And you've got these suspicious spikes on 6s and 12s. You go talk to the ops guy. Turns out that's when you're backing up, and you're backing off from your master database, not your clone. And that's slowing everything down. So if you have this picture and you go back to your boss, maybe they'll get it. Maybe people will start understanding what you're trying to do instead of just barfing numbers at people. And the moral of the story is that data is proof. Hunches aren't good enough. The more important your problem is, the more important it is that you actually understand what's going on and use data to defend your opinions. Also, people pattern match. We are evolved as human beings to find patterns, even when patterns aren't there, oddly enough. And the more you can use this ability, the more effective your communication will be. Finally, pictures are universal. Who here works on a team where there are multiple first languages? You work with people from different countries. Yeah, a lot of you. I've worked on several international teams, and this is where I found the value in using pictures the most. Because even though everyone spoke English, when panic happens, brains shut down. And when brains shut down, you need to take it back to something that's really easy, and for a lot of people, visual helps with that. Also, I find that pictures are really good when you're having to communicate with non-technical people. If you need to explain to your CEO why you can't take backups from your primary database and you need a secondary database, pictures are probably a great way to do that. So a brief overview of my talk. This isn't this talk. This is more this talk. We're going to talk about ways to take... Yay, they got it this time. We're going to talk about ways to take data and just kind of throw it at some existing tools so that you can get visualizations that are quick and dirty out fast. There are all sorts of ways to make pretty visualizations, and I'm not going to be talking about any of them. We're going to be talking about stuff that looks like this, or maybe like this. We're going to be talking about ways to spend 10 minutes, maybe half an hour, and come up with something that can help you get past the panic and actually get your point across quickly. Some expectations, I have 95 slides left. This is going to go fast. Also, this is very code heavy. This is focused on people who write code on a daily basis. This is for the doers in the audience. The slides and code are available if you go to my blog, thagamizer.com. There are links. They're from last week's version of this presentation. This one is the advanced version, because y'all are really good. So I will post the rest of the slides and the rest of the code this afternoon if you want to follow along. If you start getting lost, go for the big ideas. Come talk to me later or go through the presentation later. It's pretty straightforward if you can actually look at the code. So there are 3 sections. I'm going to talk about the graph gem, I'm going to talk about Highcharts, and then I'm going to talk about data extraction. We're going to start with the graph gem. Graph is a Ruby gem, so you install it like a Ruby gem. Graph hooks into a tool called graphviz. I highly recommend you use Homebrew to install it. There is a WYSIWYG editor you can download. Apple has been doing lots of fun things with their C compilers and other such developer tools recently, which have made the one you download less than stable. If you are at all comfortable in command line, go with the brew version. It's been much more stable for me over the last 2 years. Some examples of what you can make with graph. Here's a graph with Ruby exceptions. That's all of them. Standard Ruby. I think this is Ruby 1.8. There's a lot of them, but you can see that there's hierarchy. You can see where there are subclasses, superclasses, and relationships. You can also graph your Rails associations. This is a UML-ish diagram of the classes, the models, in a side project I have, which is tracking weightlifting performance. So there's lifts and goals and exercises and athletes and all those things. And the little arrow types are indicating one-to-manys or has-manys and all those kind of relationships. But the place where graph really shines is graphing dependencies. And the canonical example of dependencies that I've found useful to use is like the idea of a curriculum, where you have classes that have prereqs. So here's the curriculum for my alma mater, the CS curriculum. You don't have to read it. All you have to know is that you can see that there's kind of like first-year classes, and then there's a stack of second-year classes, and then there's a stack of third-year classes, and so on as you go to the right. And the dependencies build up between classes. So graphviz is based on a language, uses a language called dot. Dot is a simple language for describing graphs. Graphs in the graph theory sense of edges and nodes. Graph allows you to also describe attributes. So maybe you want this node to be purple, or you want to use Comic Sans for some reason, or you want this particular thing to have really huge font. Graph allows you to specify the nodes and edges, but also allows you to specify attributes of your graphs. To view dot files, there's a couple tools. GraphViz, the WYSIWYG editor I talked about just a couple minutes ago. Also, there's a tool called Tulip if you have really big data sets. Tulip is not beginner-friendly. I find it slightly confounding, but it does let you view really big files. Also, if you are a fan of OmniGraffle and the Omni products, you can import your dot files into OmniGraffle and it will happily show them to you, but you can't edit them and then export them back in dot. So, some basics. Simplest graph possible, a single node. The graph gem gives you diGraphDo, allows you to pass a block to the digraph method, and in that block is where you specify your graph. So in this case, we have a node named B. That is its key. Nodes are the nodes are a hash. So that's specifying that we have this node named B. Turns out B is not a very interesting name for our node, so we can put a label on it. We'll say hello. This is a hello world type example. So now we have a node with the name B, but the label's hello. Still pretty simple. Now we need edges. Here's this awesome thing about GraphViz, is that it implicitly will put the nodes in if you say that there's an edge between two things. So if you say there's an edge between A and B, it's like, okay, well, I need a node A and a node B as well. So you can see in this example, there's edge from A to B. The edges are in the direction that you read, so from left to right. So the arrow is going to point from A to B in this case. All of these are good, except you can't share these right now because we haven't taught you how to save. There's a save method. Call it with the file name. This save is a .dot file. You can also see that you can make cycles in this example. I don't actually use .dot files at all anymore. I only export to various image formats, and the only time I ever even read the dot file is if I'm trying to debug something when I'm trying to add features to graph. Turns out exporting is really easy. You just pass a second parameter to your save method that tells you the file extension you want. There are between 50 and 100 supported by graphviz. If you want to check it out, you can go to the graphviz documents at graphviz.org/doc/info, and you can see all of them. There are many that I did not know existed as file types. It's awesome. I use PNG, JPEG, and PDF almost exclusively for what I need. So that's .101. Now we're going to go to the advanced stuff. And the advanced stuff is all about putting extra meaning into your graphs. So saying that specific nodes are related to each other, or maybe showing processes. And one of the ways you can do that is with shapes. You can think about, I don't know, who all had to make flow charts when they were learning CS, or maybe in elementary school. You can think about how you'd have different shapes for decisions and other things. I often use boxes for all of my nodes because you're losing the least amount of space to rounded corners, and I tend to make graphs that are pretty information dense. GraphViz makes that, the GraphGem makes that easy. You just call the boxes method, and it makes all your node boxes. You can do, uh-oh. I know. You can use other shapes, triangles. Here we're painting triangle onto the node attributes collection, which is all the attributes for our nodes, oddly enough. You can also do different shapes for different nodes. So in this case, we've done an edge from A to B and an edge from B to C, and then we also have, we're painting the node A with triangle, the node B with circle, and the node C with diamond. Shapes are awesome, but what I found is even more helpful is color. People really like seeing color, and they can see differences in that a lot faster, because you don't have to look at fine lines. So if you want to make all of your nodes and all of your edges one color, we can do it the same way we made triangles. You paint your node attributes with red and your edge attributes with blue. Again, these are just collections that say the attributes of these things. It doesn't actually help you if you want to group things or say things are related. What you really want to do is make things different colors. So here I've made my nodes filled, so it's easier to see the colors, and then I'm painting the G node with green, the O node with orange, the R node with red, and the P node with purple. Like most things that do graphics, you've got a handful. I think there's between 24 and 50 different color variables that are defined already. So I'm design impaired. I'm guessing there are some people in the audience who are also design impaired and really shouldn't be allowed to pick colors for things. For those of you, colorbrewer2.com, I love this site. It is specifically designed for give color advice for maps, but it happens to work really well for other kinds of data visualizations. This is what it looks like. You have a map, example map on the right-hand side. On the left-hand side, you've got a bunch of little palettes, like paint strips at a hardware store. And what it does is it lets you filter those. Maybe you want ones that are printer-friendly or photocopier-friendly. Maybe you want ones that are colorblind-friendly. Because looking around this room, there are a lot of guys. There are probably between 2 and a dozen people in this audience who are colorblind. So a couple hands waving. You can also use color to show intent. And that's one of the things I really like about Color Brewer is it makes you choose what your intent is. Do you want to show colors that are categorical or diverging or sequential? And I'll give examples of those in a second. And these color schemes are built into GraphViz. You can look up their names on the GraphViz documentation, so org.doc.info colors.html, and they're also built into the GraphGem. So our node attributes are filled again, and we're going to say color scheme, and we're going to pass it a symbol for the name of the color scheme, and then we're going to pass it the number of colors we want to use. So we're using color scheme called set1, and we're going to use 4 colors. And then same way you were doing the colors before. That gives you the variable C1 through C4, because we have 4 colors, and you paint node A with C1, node B with C2, node C with C3, and all the way down. And what you can end up with is these are 3 different color schemes. The leftmost color scheme is a sequential color scheme. Think about those maps on election night where they have reds and blues, and sometimes you see the ones with the purples in the center. This is showing where a node falls on a continuum between 2 extremes. That's a diverging color scheme, sorry. This middle one is a sequential color scheme. That's showing you the amount of some attribute that a node has. And one of the canonical examples of this is those maps they have of poverty. The node that's the most purple might represent a high poverty area. The node that's the least purple might represent a low poverty area. And the last color scheme is a categorical color scheme. These are designed so that people don't assume that there's any relationship between the colors at all. So if you have apples and oranges and kumquats, you would want to use a categorical color scheme so people don't assume there's a relationship between the colors that isn't there. So that's all I'm going to say on graph. Now we have charts, and look at some examples. So this is an example from that weightlifting app I was discussing earlier. You can see that there's a line chart and a bar chart and 2 axes and a whole bunch of stuff going on. This is your standard bar chart. And both of these were generated with a tool called Highcharts. Highcharts is free for non-commercial use, and I've used it at a couple places commercially, and the prices were very reasonable. It is a web-based thing, and so it uses JavaScript. So you have to have a page, and the basic page generates something that looks like this. This was the minimal amount of code I could get an interesting chart. I just kept deleting stuff until it stopped rendering, and then I put the last thing in. The requirements for your page is you need to have jQuery and you need to have the Highcharts JavaScript library. I said I'm not going to teach you guys how to embed stuff because your designers will thank me. So I highly recommend you just link to Google for JavaScript, or Google for jQuery, and you link to Highcharts for the Highcharts library. If you want to download it and serve it yourself, you can, but don't. Here's the basic page. I don't expect you to be able to read this, but there isn't much here, and that's kind of the point, is all of these tools are about doing something quick and dirty so you don't have to put too much effort into making a picture. We'll go through this a little bit, though. Those 2 things that I've highlighted, standard HTML tags. Everyone following? OK. That's including jQuery. That line includes Highcharts.js. You can copy these and paste these from the Highcharts documentation. That's what I did. That is a div for your chart to live in. You need a place for your chart to go. Make it a div. I called it my chart. That's the interesting bit, and we're going to dive into that a little more right now. Same code pulled out with the picture next to it. So you wrap everything in a JavaScript function. You use jQuery to find the div, and then you call .highcharts and call the Highcharts method, and you pass in some data. The absolute minimum you need is you need to specify a single series that has some data, and data can be an array. In some circumstances, you may want it to be a hash or an array of tuples. In this case, it's just a simple array of 10, 5, and 3. You can also have multiple series, which is why, if you're paying very close attention, you'll note that the series attribute is an array. It's not a single thing. This chart is really boring, and it actually represents an informal poll of editors in use at a given Seattle RB meeting. We'll pretend that it does. And so the x-axis values in the previous slide were 0 to 2, because those were the array indices of my data array, but it's actually categorical data. So we have these categories, Emacs, Vim, and other, and we'll say that those go on the x-axis. So x-axis, attribute, categories, and the strings. And I had some training as a scientist before I realized that computers are less likely to kill me than a chem lab. And so I learned that you really shouldn't represent categorical data with a line graph. Really, it should be some sort of bar chart. And so you can change your chart type to column, and now all of a sudden you have a column chart. You only had to change a couple lines. Graphs should have titles. You can add a title exactly the way you'd imagine you would. Title attribute, give it some text. You have a legend at the bottom, and if you want to have that legend be something other than series 1, you can give your series a name. In this case, we'll call it editors. It's just another attribute of the series. And you can also label your y-axis with a label. In this case, we're going to say number of people, so it doesn't say just values. Again, it's just a title. You pass it a string. So that was all very simple. Highcharts 102. You can do things like pie charts. In this case, all we had to do was change the chart type to a pie. And in this case, the data needs to be a set of tuples, the category and the count. And we change that up, and everything else works. You can still use your same title. You can still use your same axis labels, all that. Highcharts has a ton of chart types. The basic types are line, spline, area, column, bar, pie, scatter, area, range, area, spline, column, range. Also, all sorts of subtypes within these. Do you want stacked areas? Do you want donuts? Do you want spider webs? Everything that you could possibly want is included, and you can overlap them like this, where you have a line chart and a column chart at the same time. And if you look very closely, you'll notice that this chart has two y-axes with two separate sets of values. So I tried a lot of different tools when picking the charting tool I was going to talk about today, like Google Charts and several others, and very few of them made two separate sets of y-axes easy. The reason I really like Highcharts is it works the way you'd expect it to. You just pass two hashes of values to the y-axis key. So in this case, we're going to make it an array. one set of values describing one y-axis, some labels with some style info and the title. A secondary set for the other axis. In this case, you're also saying that it should go on the opposite side of normal, which in countries that read left to right, this means it should go on the right. So that's the basics of how you do Highcharts. There's tons of stuff there. Their documentation is awesome. And if you do anything financially related or stock market related, they have Highstock as well. That does all sorts of really cool stock market and financial market directed graphs with just as much ease. So last section, data extraction. I like this part. Lots of techniques for data extraction. If I'm dealing with HTML or XML, I'm almost always going to go into GoGaRuCo. And I'll show a tiny bit of that, but guess what? The next talk is also about GoGaRuCo, and I'm not going to steal anyone's thunder. I also use JSON because more and more it's easy to find your data in JSON form. And if you can get it that way, great. We've got built-in tools in Ruby, or we've got access to tools in Ruby that make parsing JSON easy. CSV, if you work with people who only use Excel, you can probably get them to give you a CSV. And a note from the trenches on this one. It may seem like you can parse a CSV with a regex. Unless it's really simple, don't. Crazy stuff happens when you have strings with commas in them and you do that. There actually is a CSV specification if you really want to go look it up. It's kind of insane for something that seems like it should be so simple. And finally, regexes. They're quick and dirty, and for most things, they actually work really, really well. I like to use rubular.com to figure out what my regex should look like and test it against sample data. Many editors have regex building tools built in. You can build it piece by piece. You don't have to know exactly what your regex should look like from the top. So I'm going to show how I built up that CS curriculum graph, because I based it on screen scrape data. This is the course description page from my college's website. They didn't give me a nice data file to build that. And all the information I need to build that graph is here, because you got the course numbers, you've got course titles, and the prereqs are in that gray box somewhere. And we're going to end up with something that looks like this. And here's the code. There's 50 lines there, including white space, and most of those are actually made shorter so I can fit them on slides. I don't expect you to read this. We're going to go through it in 3 big hunks. The first hunk, this is the requires and inits. So zooming in on that section, we have require graph, require GoGaRuCo, and require open URI. This is the location of that document, and then we're going to use open URI to open it and get an IO object back, and then we're going to use GoGaRuCo HTML to parse that and give us a GoGaRuCo document. I'm defining a quick convenience method called normalize for the course numbers, because sometimes it's CS and a bunch of spaces, sometimes it's CS and no spaces before the numbers. So this method just takes something that looks like this, CS space 105, and smashes the 2 pieces together. It just strips out all the white space. And then we're going to have a courses collection to hold all the stuff we extract. And finally, the last piece is we're going to pull everything out of that GoGaRuCo document that matches the CSS selector, CRS description without any vowels - header. And that's that gray box. That's all you need to know, is that just pulls all the information in the gray box out so I can ignore the navigation and everything else on that page. So that's the first third of that 50 lines of code. The second third is actually the data extraction. And again, we'll go through that line by line. So we're going to go through each of those course descriptions, each of those gray boxes, and we're going to make a hash to represent the data in each course. This next section extracts the number in the title. We'll zoom in on it a little bit. And again, some CSS magic with GoGaRuCo to pull everything that matches course description title out, take the text of it, and then split it on the dot. So everything looks about like that call out on the page, CS105 dot space computer systems. So we're just going to split it on the dot into the CS105 and the computer systems parts. And then we, and then we save those off to our hash. So this next section parses out the prereqs. I don't know why, but the prereqs were in a definition list. Okay, we can work with this. So really what we want is the content of the first DD under a DL. CSS to the rescue again. We can pull out the first DD under the DL, or DD's under the DL, grab the first one, and then take the text of it. That gives us something that looks about like that. There may be one, there may be many. So we use string scan to find things that are CS, some spaces, and some numbers. And that gives us all of the things that match that as an array. about like that. And then we run them through that normalize function and store them off to our course hash as the prereqs. So that's the save step. And the last part of this data extraction piece is just pushing the course onto that courses collection that we made in the initializations. Last third. This is the part that draws it. Our old friend diGraphDo. We're going to call the method rotate. GraphViz defaults to doing graphs top to bottom. For most of the stuff I do, I actually want them left to right because I want to hold a piece of paper the long way, not the tall way. And we read that direction, so we're going to call rotate, which takes care of that. And we're going to use boxes because I don't want to deal with the space that rounded corners take up. So got through that, got that. We're going to go through each course, and we're going to make a node for the course where the key to that node is the course number, CS105, CS10, whatever. And the label is the title of the course. Computer systems, architectures and operating systems, that kind of thing. We're then going to go through all the courses, and we're going to draw an arrow from the prereq to the course. 2 eaches, nested eaches, all through the courses, all through all the prereqs. That's that code in a little more detail. Finally, it turns out that there's several courses that have no prereqs other than by instructor permission, and I don't care about those right now. So they're all orphans in my graph. They're not connected to anything else, and graph the gem provides you a .orphans method, .orphans a. And so we're going to take all those orphans and we're going to pull them out of the graph with remove node. Finally, we're going to save this as HMCCS PNG, and what we get is this. So there was 50 lines of code there, but as you can see, they're not that complicated. You can go through them pretty quickly. If you understand the basics of looping in Ruby, you got this. Another example of data extraction is I do a lot of this on logs. When I'm using Rails, I really like to have a syslog logger type gem or some other type of gem that gives me better formatted and more informative logs. I really like syslog logger because it gives me the PID of the process that made each log line, which means I can see individual unicorns. So you can see how well the load is being distributed across your different workers, which is amazingly handy at times, and you're like, maybe we need more workers. No, actually we don't. We need fewer workers because we're not using the ones we have. In this case, we're parsing out my syslog from yesterday, and we're going to go through each of the things that are passed in. We're going to go through each line, and if they match this date regex, which checks for a date and then extracts the source process name of that particular line, and puts it, it's a match, so it puts it in $1, and we're just going to increase a count hash that counts how many times a given source shows up in my logs. And then you can end up with a histogram like this. And if you're paying close attention, you'll note that that y-axis is logarithmic. Yes, Highcharts does that too. All you have to do is say, I want to let you say logarithmic to the type of the y-axis, and it gets the rest of it for you. So yesterday was a good day for my kernel, apparently. So a couple minutes left. I want to give special thanks to Ryan Davis for writing and maintaining the graph gem and for helping me with Highcharts. And I want to thank Aaron Patterson and Mike D'Alessio for no GoGaRu because it's awesome. And if you ever have to process XML or HTML, really, really use this gem. So thank you guys very much. If you use any of my content to make something awesome, let me know. I want to see the cool stuff that you guys build. If you have any questions, ping me. I'll be around. You can send me email. You can hit me up on Twitter. But I really want to see what people build with this because everyone's like, I used your stuff to build something. I'm like, can I see it? They're like, I don't have access to it right now. Show me the awesome stuff you make. So thank you guys very much.